Hello again for one last time because we need to talk about the exam 3 and review for it. And this will be it. This will be our final exam. So this unit is Unit 3. So this is a Unit 3 exam, right? So final exam, but it's covering only the last unit, right? We don't have any um, cumulative or comprehensive exams in the course. So it's going to look just like the previous exams, right? Covering the material in the unit, 60 questions, 80-minute timer. This review you should again think of as a high-level overview of the material, not necessarily a detailed study guide. The exam will be randomized for every different student, so I've got a lot of questions in there that cover all of the various topics that were covered in the original lectures. So this is really just kind of meant to hit the high points to provide some, overarching structure and organization to the far more detailed original notes and lectures. So use this as a guideline for that and to go back to the original notes to dive into the specific details associated with each one of them. So let's go through this here. We'll start with chapter 9. We talked about judgment and decision making. We've talked about Kahneman's system 1 thinking and system 2 thinking, right? So those fast, intuitive kinds of judgments versus more slow, deliberate kind of judgment processes. We also talked about the difference between the normative or rational based approaches, where they make some effort to define rationality, and then design studies that show how people are usually not very rational, versus what I had emphasized as a descriptive approach, which is to not sort of try to define in advance what would constitute some sort of optimal or rational approach to decision making, but rather just to approach human behavior in this situation from that non-judgmental, let's just see what people do kind of an approach. The rationality approach has primarily been focused on how people misuse base rate statistics, and generally don't use probability information very accurately. I compared a lot of the experimental tasks in that research to homework questions or exam questions in a statistics class. And of course, not everyone gets a perfect score in such classes. So, of course, in that sense, people surely are not perfectly optimal and rational. But it's not quite clear that that's the necessarily the best way we want to try to characterize human judgment and decision making. As part of this discussion, I also raised the idea here of there being a difference between well-defined and ill-defined problems. And one way to think about rationality or optimality are using algorithms, but algorithms pretty much only work for the specific sorts of well-defined problems they're designed to solve. Ill-defined problems don't really ever have an algorithm that can be used to solve them. And so that's where the heuristic kind of comes in. And the concept of a heuristic is this rule of thumb that is maybe not perfect, but works well enough. And when you think of factoring in human limitations like attention and working memory limits, combined with the flexibility that humans have when dealing with these kinds of ill-defined problems, that's what makes human reasoning more unique. Down below here, onto the topic of the specific biases that were studied from this research paradigm here, we have the representativeness bias, the availability bias, various other base rate of errors, and the gambler's fallacy, and so forth, which is again a kind of a misperception of likelihoods, or even the Monty Hall problem. The right, so that all of these are examples where people are just not thinking in terms of probability and statistics in an optimal way. Um, we also looked at behavioral economics here and talked about rational choices and prospect theory, and the effect of framing a problem in terms of gains and losses and how that's going to influence people as well. And we also then talked about how this can change over the lifespan, because people's tolerance for risk is known to change across the lifespan. And when we're young, uh, risk-taking behaviors are oftentimes quite high, and that might have something to do with the emergence of pathways in the reward system of the brain. The dopaminergic reward learning pathway is highly active from adolescence into early adulthood. Meanwhile, it changes as we get older, and we find older adults are highly risk averse and error averse. So when things are framed in terms of risk and loss, maybe that's going to influence behavior as a function of age. That's rarely accounted for in this kind of research here. Something else worth mentioning here is that separate from the optimality of logic and so forth is the role of emotion in judgment and decision making. And I had some notes in here about how when people are presented with some of the infamous moral dilemmas like the trolley problem, certainly the reasoning centers of the brain, like the prefrontal cortex, are active, but so are the emotional centers of the brain. And the idea is that emotion may play an important functional role in helping us anticipate the emotional consequences of moral decisions. And that might influence, again, our tendency to take risks. And that's certainly a place where emotion is perhaps as much as important as logic would be. We also had a section in one of these chapters, I think that was moving into chapter 10 on reasoning. And so we talked about deductive and inductive reasoning. So make sure you can define both deductive and inductive reasoning, right? So the definition of deduction is reasoning from the general to the particular, and inductive logic is the converse of reasoning from the particular to the general. As examples of deductive logic, we talked about conditional logic, conditional statements like if-then sorts of arguments. And we talked about the valid forms of that, known as modus ponens and modus tollens. But we also talked about some fallacies that can arise if you misuse these rules, and that's affirming the consequent and denying the antecedent, are the kind of the core kind of conditional logical fallacies. But we did mention a few other forms of fallacious reasoning. So we got the ad hominem argument, begging the question, slippery slope. Details, again, are found in the original notes. We also saw here that in certain tasks that require people to use deductive logic to solve problems, that oftentimes people's sensitivity to the validity of a deductive argument is less than optimal. So rather than sort of keying in on modus ponens or modus tollens, sometimes people will commit either in affirming the consequent or denying the antecedent fallacy, because what happens here is that they might let the believability of an argument influence their judgment of validity. So the way these studies work, it's in the original lecture, is that people are presented with logical arguments that are either deductively valid, meaning they follow those rules of modus ponens or modus tollens, or they are deductively invalid, which means one of these two fallacies here. But the conclusion of the argument could still be framed as a believable conclusion or a non-believable conclusion. And what we're seeing is that the believability of the conclusion is influencing people's judgments of validity, even though they're not asked to judge whether they agree with the outcome. They're simply just asked to judge whether the argument is itself valid. And so, again, they're focusing more on whether they agree with the outcome here. Another example where people struggle with deductive logic is the Wason card selection task, where there's a rule there in terms of what pattern exists between the front and back of the cards. And one of the things we saw there is that while people do commit a logical fallacy when responding to this task, when the task is reframed in terms of situations and contexts that are a little bit more everyday, real world kinds of situations, oftentimes these fallacies disappear. And that would suggest that people can think logically and avoid fallacies, but it becomes harder when the nature of the task becomes a bit abstract and not very much like real life, which the Wason card selection task is not very much like real life. Down under inductive logic, we talked about pattern recognition. This was also where we brought in the issue of confirmation bias, because that relates to kind of maybe a misrecognition of a pattern of events. So we talked about it there, but of course it does connect back to some of the base rate fallacies as well. Okay. Also, in this set of topics, we covered the problem-solving literature. We talked about the Gestalt approach and their definition of the reproductive and productive thinking, and Kohler's research with chimpanzees on insight into problem-solving. We talked about other limits of problem-solving, like functional fixedness. People have difficulty envisioning novel uses for tools, or the mental set research, where people sort of get into a habit of solving a problem using a specific approach, and they get stuck on that approach. And when the nature of the problems change and the approach doesn't work anymore, people have trouble adapting to those new versions of the problems, even if the new versions of the problems are actually pretty simple. We also looked from the information processing view here, kind of remembering back to the first week of the course and thinking about how the early information processing and cybernetic stuff influenced cognitive psychology. And that's very relevant here to the problem solving research, looking at the early use of computers to try to use them to solve problems, and the early ideas related to AI and the concept of a general problem solver and a Turing machine and all of that. We looked at means ends analysis and brute force methods. And then coming into the 80s, we see Anderson's ACT, or adaptive control of thought, idea, and how he uses problem solving by connecting declarative knowledge to procedural knowledge. And that's the claim of how problem solving works there. On the topic of solving problems, then this also helps us maybe think about the concept of expertise, because one of the things we could say is that when someone becomes an expert, that means that they're an expert at solving problems. But does that mean that they can solve any kind of problem because maybe they have a high IQ? No, not necessarily. Expertise is typically very domain specific. So you become an expert in some blank thing. I could say I'm an expert in psychology, for example, or at least some forms of psychology, like perceptual psychology mainly, right? Not clinical psychology for sure. So pretty domain specific there. But the idea is, now that we have that kind of understanding, what is it that an expert has and knows that makes them an expert? Is it just a bunch of knowledge? Sure, but it's more than that. It's about seeing connections, right? And so the pattern recognition business there is important. That's inductive logic potentially. We also talked about how this kind of pattern recognition enables you to organize information a little bit more efficiently, and that reduces working memory load. So then this improves cognitive load during a problem-solving task. We also looked at, of course, the importance of training and practice, and talked about the 10,000-hour rule as a myth, and suggested that deliberate practice, structured practice with goals and feedback and good mentoring, all of that stuff is pretty relevant as well for the formation of expertise. And we also talked about one study that looked at forward and backward reasoning and how that worked out as well. So again, you can go to the notes on that here. Next chapter dealt with knowledge and intelligence. So starting with knowledge, we can talk about categories here. We talked about how are categories represented in the mind, and we talked about templates and prototypes and the essences and so forth, and entertained the possibility of affordances as providing insight here. We also talked a little bit about how artificial neural networks serve as categorizers or classifiers, and so they can work in this way as well. But one of the things we also mentioned is that human tendencies to categorize the world oftentimes are pretty fuzzily defined, and that we can have many things where there's room for debate over whether something is a member of one category or another. Boundaries between categories are not necessarily rigid and fixed. Second part of this chapter then focused on intelligence and IQ testing. So we've talked about trying to define what is intelligence. We covered sort of the nature nurture part of it a little bit there, right? Are we born with it, or is it something that we learn? A little more time talking about the concept of general intelligence, or G, right, versus domain specific skills. We saw how the modern IQ tests, like the Wechsler scales, subdivide intelligence into these different kinds of abilities, like working memory capacity, cognitive control, and speed of processing factors, and how those things influence our performance on the tests, how they're related to G. But also the idea is that when it comes to predicting achievement, whether it's in school or career or life in general, IQ has some role in predicting especially academic achievement, but we also mentioned that there's a variety of other factors that influence success here. So achievement, expertise, and all these things are more than just talking about IQ, right? On that topic of IQ testing, we talked about the history of it a little bit. So, the origins with the Binet-Simon test, and then the Stanford Binet test before we get to the Wechsler scales and so forth. We looked at other definitions of intelligence, talking about crystallized and fluid, or Sternberg's has the triarchic theory, but the third one called contextual intelligence was a sort of an important departure there. So you want to look at that. And then Gardner's theory of multiple intelligences is a bit controversial, but again, you want to kind of review that, but understand part of the controversy there about whether or not we're really talking about a form of intelligence, or is it skill or personality? And then emotional intelligence again relates to our skill when it comes to understanding others and ourselves as well, which was also a component in Gardner's theory too. We also have cognitive development in here as well. So we talk about IQ and how that changes as children develop. So we want to understand something about cognitive development. We covered Piaget's stages. So sensory motor stage, pre-operational thinking, concrete operational thinking, and formal operational thinking, which culminates then with humans mastering deductive logic essentially here. We saw some concerns though, right? So we talked about in the sensory motor stage, Piaget is making a claim about how children are developing object concepts. That relates to the knowledge and categories business in the first part of this chapter. And his research on object permanence is meant to inform how this is developing. But we also noted that there were some criticisms of the search task that Piaget developed, that maybe it's measuring some sort of problem solving or working memory limits, since rather than actually measuring knowledge of object permanence. And we saw there were other techniques like the violation of expectation method that might be a better measure of object permanence. And that might change some of the conclusions then, because children much younger than the 9 to 10 months that Piaget identified are able to pass the violation of expectation measures here. We also saw some other interpretations of the A not B task using the dynamical systems approach there. We also entertained the role of expertise and wisdom by looking at a modern idea that potentially extends Piaget's four stages with a fifth stage called post-formal reasoning. So make sure you go back and review what the characteristics of post-formal thinking are, how that connects to the concepts of being an expert at life, and what does it predict our tendency to maybe not fall prone to some of the classic reasoning biases or judgment biases. Do we want to equate that with wisdom? Wrapping it up with social cognition, we talked about the idea of mentalizing others, which we call theory of mind, and how we measure that with something like the Sally-Ann test and other tests, different variations of theory of mind, like theory and simulation theory. We also looked at some of the brain modules, or the ideas that there are brain modules involved, the medial PFC and other brain regions, as well as the default mode network. So we cover all of that. We also talked about some of the judgment biases that are known to show up. So this connects back to the other judgment biases. In this case, fundamental attribution error and stereotypes come up in that topic. And then we wrapped it up by talking about social perception. We looked at the being able to predict the behavior of someone and who we are maybe interacting with under the context of, say, the prisoner's dilemma, perceiving whether they're truly being cooperative or whether they're being competitive, and whether or not we might be able to perceive that directly. We talked about how motion and the way someone moves could convey information about their underlying intentions or motivations. So we looked at the Heider and Simmel demonstration, which is a really old demonstration that tends to show that we have a natural tendency to see these things, even in a simplified display like that. More recent point light research with point light actors points that, again, there's maybe a lot of information that's conveyed through the way people are moving, and that people watching these point light videos can accurately recognize cooperative versus competitive movements and tasks here, which then raises the idea of direct social perception. So we entertained this possibility that we could directly perceive the social intentions of other people by observing their embodied cognitions here, right? How they move, how they interact with us, proposing this idea known as kinematic specification of intention. We and then talked about perception action coupling with joint action and how that might involve direct social perception, uh, with a slight extension towards social robotics there. And we wrapped it up finally with, since we were talking about embodied and active cognition, we bring in all of the other E's of extended and embedded, as well as even ecological. And Lewin's research on the psychological field and field theory also kind of connects the dots here with all of that stuff. So you can go back to the original notes for that too. Well, that wraps it up. So as usual, I guess I just closed that, right? Let me know if you have any questions. This being the last exam, make sure you get it in on time. And I will certainly post announcements in Canvas to make sure we're all aware of when the deadlines are. Don't forget, I have office hours. So far, no one in the class has come to my office hours. So check it out and ask me some questions if you feel you need to. And best of luck.